Welcome to Aviation World.
Welcome to this presentation covering the pressurization system on A320 series aircraft. Like the majority of the aircraft systems, the pressurization system is fully automated. It adjusts the cabin altitude and rate of change of altitude to ensure maximum comfort and safety and requires minimum input from the flight deck crew. The pressurized areas are cockpit avionics compartment, cabin cargo compartments. Throughout this lesson the term cabin pressure will be used to refer to the pressure in all of those areas. The unpressurized areas are tail cone, landing gear bays, nose cone. Pressurization system operation is fairly simple. Air is supplied from the air conditioning packs to the pressurized areas. An outflow valve, controlled by two pressure controllers, opens and closes to regulate the amount of air allowed to escape from the pressurized areas.
Each controller operates an electric motor which opens and closes the valve as necessary. Each controller and its respective motor are referred to as a system, System 1 and System 2. Only one system operates at any one time, with the other system acting as a backup. A third electric motor is installed to provide manual control if System 1 and System 2 fail. This provides for complete redundancy. The system also incorporates two safety valves installed in the aft bulkhead. They open and close automatically to avoid excessive positive and negative cabin pressure differentials. The controllers receive inputs from other aircraft systems, such as the landing gear control and interface units for ground or flight status, the thrust levers to determine if takeoff has been initiated, the air data inertial reference systems for vertical speed and current altitude information.
Another source of information for the pressure controllers is the Flight Management System, FMS. This enhances the controller's ability to properly control cabin pressure. The FMS provides information such as the planned cruise altitude, the time required to get to cruise altitude, the length of time at cruise altitude, planned beginning of descent, the pressure, altitude and field elevation at the destination airport. That concludes the overview section. It's time to learn about the controls and indicators. We will begin our discussion of controls and indicators by looking at the cab Pressurisation page. The pack and ventilation depictions at the bottom of the page are discussed in lessons covering those systems. The current position of the outflow valve is displayed. Normally, the outflow valve is displayed as you see here.
The outflow valve is displayed in amber if it is nearly full open in flight.
The SYS1 and SYS2 icons indicate the status of the two system controllers. In this example, Controller 1 is using its dedicated motor to open and close the outflow valve as necessary. In this example, Controller 2 is active. The controllers automatically alternate active roles shortly after each landing. In this example, Controller 1 has failed. This is indicated by the amber SYS1.
In this example, neither controller is active. The outflow valve is being operated manually. There will be more on manual pressurization later in this lesson.
The single safety valve icon represents both safety valves. In this example, the safety valves are in their normal closed position. In this example, at least one of the safety valves has opened automatically to relieve excessive positive or negative differential pressure. Subscribe to our channel by clicking subscribe button. Also click the bell icon button to get notified directly for latest uploads. The cabin differential pressure, delta P, is displayed in digital and analog format. In this example, differential pressure is within limits. In this example, an excessive positive differential pressure has been reached. The digital indication pulse is green if a higher than normal pressure differential is detected on final approach. Cabin vertical speed is displayed in digital and analog format. It indicates the rate of change of cabin altitude in foot/min. In this example, cabin altitude is climbing at 1000/min. The digital indication pulse is green if cabin vertical speed is excessive.
Cabin altitude is displayed in digital and analog format. In this example, the current cabin altitude is 5,000 feet. If cabin altitude is excessive, the digital and analog indications are displayed in red. An ECAM message would also be displayed.
The digital indication pulse is green if cabin altitude approaches the red arc. Destination landing elevation is displayed at the top of the page. The active controller uses this information to manage the depressurization schedule during descent and arrival.
In this example, landing field elevation has been set manually. How is this done? Let's move on to the cabin pressurization panel and discuss it. The cabin pressurization panel is located on the forward right portion of the overhead panel. The landing elevation knob is normally left in the auto position. In the auto position, destination airport elevation is provided to the pressure controllers from the FMS database. In this example, the FMS entered destination has an elevation of 580 feet and is being automatically provided to the pressure controllers.
Pulling and turning the Logi LEV knob manually selects a landing elevation. This would be necessary if the destination airport is not in the FMS database or if both FMGCs fail. Advance to manually set a landing elevation of 810 feet.
Manually selecting a landing elevation does not affect the automatic operation of the pressurization system. The active controller continues to control outflow valve position. The mode select push button is normally left in the auto lights out position. In the auto position, pressurization system operation is entirely automatic. In the manual position, the crew is responsible for outflow valve position, and the outflow valve must be moved manually using the manual vertical speed control switch. The use of the mode select push button and the manual vertical speed control switch will be demonstrated in the abnormal operation section. The guarded ditching push button is used to close all of the fuselage openings below the flotation line. Selecting the ditching push button on commands the following items to close: the outflow valve, the emergency ram air inlet, the avionics ventilation inlet and extract valves, the pack flow control valves, and the forward cargo isolation valves. The outflow valves will not close if the mode select push button is selected to manual. The ditching push button may also be used to prepare the aircraft for de-icing.
Pressurization information is also displayed on the cruise page. The indications are essentially the same as those on the cab press page, with one minor difference. Cab V/S is normally displayed digitally in green with an arrow indicating the cabin altitude trend. In this example, the cabin altitude is rising at 150 feet/min.
We now move on to the normal operation section of this lesson. During pre-flight, the cabin pressurization panel should be in a lights out condition. The guard should be down on the ditching push button. The landing elevation knob should be in the auto position. The manual vertical speed control switch should be in the spring-loaded neutral position.
While normally not required, if you bring up the cab press page during pre-flight, you will find that the cabin altitude is equal to field elevation. Logi LEV will indicate 0 until a destination is entered into the FMS. Notice that the outflow valve is fully open. This is the case when the pressurization system is in the ground mode. When the thrust levers are moved to a takeoff detent, system enters the takeoff mode. To avoid a pressure surge at rotation, the active controller pre-pressurizes the aircraft at a rate of 400/min, until delta P reaches plus 0.1 psi. If the takeoff is aborted, the system automatically reverts to the ground mode. At liftoff, the system enters the climb mode.
During climb, the cabin altitude varies according to a program parameters that consider the aircraft's rate of climb. The active controller schedules the climb profile using inputs from the FMS and other systems. During the initial portion of the climb prior to 8,000 feet, if the active controller detects a climb rate significantly less than normal or a descent rate greater than 200 feet a minute for at least 30 seconds, it will enter the abort mode. Cabin pressure is automatically reset to positive 0.1 psi. If a climb rate is later initiated, the system automatically returns to the climb mode after a short delay. Once established at cruise altitude, the pressurization system enters the cruise mode. The system will attempt to maintain the lowest comfortable cabin altitude without exceeding a maximum cabin differential pressure of approximately 8 psi. In this example, the aircraft is in cruise at flight level 350.
There is one exception to this. If the destination elevation is higher than the target altitude, the system maintains the higher cabin altitude. In this example, the flight is in cruise on a short flight to Denver at FL 250. The normal cabin altitude would be approximately 4,600 feet. Since Denver is higher, the system maintains a higher cabin altitude. During descent, the active controller maintains a cabin rate of descent so that the cabin altitude equals the landing field pressure altitude just before landing. For passenger comfort, the cabin rate of descent is limited to 750/min. The controller uses the landing elevation from the FMS and the altimeter setting entered into the FMS by the crew to determine the target pressure altitude for arrival. The active controller optimizes the cabin pressure descent profile based on that pressure altitude.
After landing, the system once again enters the ground mode. At touchdown, any remaining cabin pressure is released at a cabin vertical speed of 500 feet per minute. Shortly after landing, the outflow valve fully opens to ensure that there is no residual cabin pressure. Once the outflow valve is fully open, the active controller is replaced by the other controller. That concludes the normal operation section.
We will begin the abnormal operation section with a dual cabin pressurization controller fault. In our scenario, SYS1 has already failed. Pressurization control automatically transferred to SYS2. Advance to fail SYS2.
The fault light illuminates in the Mode Select push button, a single chime sounds, the master caution lights illuminate, and an ECAM message is displayed. The first ECAM step is to push the Mode Select push button and place the pressurization system in manual mode. Advance to extinguish the master caution lights and select the Mode Select push button to manual.
The pressurization system must now be operated manually.
The next ECAM step directs you to use the manual vertical speed control switch. It is active in the manual mode. It is used to manually control cabin altitude by opening and closing the outflow valve using the manual motor. It is spring-loaded to the neutral position. Notice that the ECAM step directs you to use the switch as required. We don't know what is required, but the status page will give us the information we need. So we will clear the message and display the status page.
The status page provides you with this handy-dandy chart. The status page contains target cabin vertical speeds during climb and descent and target cabin altitudes for various cruise flight levels. It also reminds you to dump cabin pressure during final approach. Remember, in the manual mode you are the pressurization controller. At this point, we will clear the ECAM and use the MAN-V/SCTL switch to move the outflow valve. Clearing the ECAM displays the cruise page. For training purposes, we have displayed the status and cruise pages simultaneously. Because the system is in manual mode, an analog display of cabin vertical speed is provided on the cruise page. Now let's discuss the use of the MAN-V/SCTL switch. In the up position, the outflow valve moves toward full open, raising the cabin altitude. In the DN position, the outflow valve moves toward closed, lowering the cabin altitude. It may take several seconds before movement of the outflow valve is indicated. In this example, assuming the aircraft is climbing, the crew should close the outflow valve slightly to reduce cabin vertical speed to the target rate of 500/min. If excessive positive or negative differential pressure occurs, one or both of the safety valves will open. A single chime sounds accompanied by master CAUT lights and an ECAM message. Notice that the ECAM action steps include if statements. In this example, you would need to take manual control of the outflow valve. If that is unsuccessful, a descent is required. If excessive cabin altitude occurs, the CRC sounds. The master warn lights flash, the cab press page is automatically displayed. An ECAM message is displayed. The ECAM steps include donning oxygen masks and initiating a descent. There are two minor pressurization system differences.
On most aircraft, if the pressurization system is being operated manually, MAN is displayed near the outflow valve indication. On some A321s, MAN is displayed in the area between System 1 and System 2. Note: on all aircraft, selecting Mode Select push button to MAN for 10 seconds and back to Auto switches the active pressure controller.
Subscribe to our channel by clicking subscribe button. Also click the bell icon button to get notified directly for latest uploads.
On most aircraft, selecting the ditching push button on commands the following items to close: the outflow valve, the emergency ram air inlet, the avionics ventilation inlet and extract valves, the pack flow control valves, and the forward cargo isolation valves. On some A321s, the forward cargo isolation valves do not close if the ditching push button is selected on. On all aircraft, selecting the ditching push button on will not close the outflow valve if the Mode Select push button is selected to manual. That concludes the differences section. Advance to see what might be waiting for you in the water.